The next section we're going to look at is if I give you two different angles, can you determine what the sum or difference equation is going to be and simplify it? So in this case, we're going to follow 4 steps. We're going to determine what sum or difference formula we're going to use. We're going to draw out reference triangles for each angle represented, because in the difference or sum formulas, there's 4 pieces. You're never going to be given all 4 pieces. Third thing is we're going to find those trig ratios you need. You might be given 2, you might be given more. You've got to figure out the ones you need. And then finally plug those into the formula and simplify. So given that the sine of x is 3/5 and the cosine of y is negative 7/25, find the exact value of the trig function sine of x minus y. So first of all, what sum or difference formula am I going to use? Well, it's going to be the sine of x minus y, which let's write that out to begin with. The sine of x, the cosine of y, minus the cosine of x, sine of y. So that's the first piece right there, writing down our expression. The second thing we need to do is we want to draw out reference triangles for each angle represented. And I see 2 angles represented. I see an angle x and an angle y. And we're told that both x and y are in quadrant 2. So I want to draw 2 reference triangles, one for angle x and one for angle y. So we'll make this one my angle x, this will be angle y. Both my reference triangles are in quadrant 2. So here the sine of x is 3/5. Sine is opposite over hypotenuse, so 3/5. Which means this side is going to be 4. It's a 3, 4, 5 right triangle, and it's negative 4 since we're in that second quadrant. My other angle is the angle y, and we're told the cosine is negative 7/25. Cosine is adjacent over hypotenuse, so negative 7 and 25. And this is a 7, 24, 25 triangle. So I need to know for my equation sine of x, cosine of y, cosine of x, and sine of y. So we know the sine of x is 3/5. I'm going to need the cosine of x right here. So let's find cosine of x of this triangle, which is going to be negative 4/5. Here for angle y, I'm going to need the sine of y right there and the cosine of y right there. So sine of y is opposite over hypotenuse, which is 24/25. And the cosine of y we were given right there, negative 7/25. So let's plug in all those values. The sine of x we said is 3/5. The cosine of y we said was negative 7/25. The cosine of x we said was negative 4/5. And the sine of y, we said, was 24/25. So now I can simplify this. First fraction is negative 21 over 125. My second fraction is a negative 96 over 125. Here, 2 negatives make a positive. So really, we've got negative 21 over 125 plus 96 over 125. Which is going to leave me 75 over 125. And that reduces down to 3/5. So the sine of x minus y in this case is going to be 3/5. Same thing with question number 6 here. I'm giving you sine of x and cosine of y's. And this time both x and y are in quadrant 4. I want the cosine of x plus y. So cosine of x plus y is the cosine of x, cosine of y, minus sine x, sine y. And I need to now figure out all my different relationships. So we'll draw 2 reference triangles. One represents angle x, one represents angle y, and we're told that both angle x and y are in the 4th quadrant. So x, we're given that sine is negative 3/5, which is going to be the opposite and hypotenuse, which means my adjacent is 4. So sine of x is negative 3/5. Cosine of x is going to be 4/5. You're going to need the sine and cosine again. For y, we're given 7/25, so adjacent over hypotenuse. So once again, we got that 7/24/25. So the sine of y, negative 24/25. The cosine of y is 7/25. And then we'll plug in these values. The cosine of x, we said was 4/5. The cosine of y, we said was 7/25. Sine of x, we said was a negative 3/5. And then sine of y, we said was negative 24/25. So 28 over 125 minus a 72 over 125, which ends up giving us a negative 44 over 125. The last example is very similar in that we're going to have to use a's and b's, but now my expressions are going to be inverses. So there's my a and b that I'm working with. The sine of the tangent inverse and the sine inverse. So really what I've got here is a sine of a plus b formula where a is tangent inverse of 3/4 and b is sine inverse of 3/5. So sine of a, cosine of b, plus cosine of a, sine b. And in order to figure out what sine cosines are, I need to create reference triangles once again. So here I've got angle A, there I've got angle B. So angle A and angle B. And I'm told the tangent inverse is going to be 3/4. Tangent we know is opposite over hypotenuse. No, it's not. Tangent, excuse me, is opposite over adjacent. So 3/4, which means I've got a 3, 4, 5 triangle. So the sine of A is going to be 3/5, and the cosine of A is going to be 4/5. Sine inverse of 3/5. We know sine is opposite over hypotenuse. So this one is going to be 3/5, and that side's going to be 4. So this one is also a 3, 4, 5 right triangle. So here we'll have the sine of B, which is 3/5, and the cosine of B, which is 4/5. So now that I've got all those pieces, I can start plugging these in. Sine of A is going to be 3/5, cosine of B is 4/5, cosine of A is 4/5, and sine of B is 3/5. Now some might ask, how did I know to draw these in the first quadrant? Because it didn't say both x and y are in quadrant 1. And it has to do with the inverse trig functions. I know tangent inverse is only defined in the first and the fourth quadrant. When it's in the first quadrant, it's positive. When it's in the fourth quadrant, it's negative. So here we've got a positive value, which means I've got to be in the first quadrant. Here, sine inverse is only defined in the first and fourth quadrant as well. 3/5 is positive, which means my triangle is going to be drawn in that first quadrant.